The video lesson for this class is about solving projectile motions. So the first thing I'm going to do is give one word, just one vocab word. You might see it in these problems, and I just want to make sure you know what it is, and that is the word trajectory. So a trajectory is the path of an object in projectile motion. So just in case it comes up at some point, which I think it probably will, I just wanted to give you that one. It's not in your reading, so it will appear. So then for projectile motion, there are going to be two major formulas that we're going to use. The first formula is d sub x, that means d with a subscript of x, is equal to v sub x times t. The second one is d sub y is equal to v sub y times t plus 1/2 gt squared. So if you take a look at some of the formulas that you have seen, the kinematic formulas, you've probably seen things that are really similar to these. The first one, you've probably seen it like this in other classes, but we also will see this as v sub x equals d sub x over t, or you'll sometimes have it solved for t. Just know that those are the same thing. The second one you've also seen as d equals v0t plus 1/2 at squared. So both of those have appeared in the past. Just a few important definitions. So you know that t is time. D sub x is going to be your horizontal distance. And then you might be able to guess that d sub y is your vertical distance. So then the v sub x is your horizontal velocity, and it's important to remember that this is going to be constant from the time that you throw a ball or whatever you throw to the time it hits the ground. The horizontal velocity is constant. The vy, however, is not constant. So actually, the y velocity is changing. In this case, I'm using vy to represent the initial vertical velocity. Okay, so these are the two equations that you're going to use the most. So let's do an example. So in this example, we have an archer standing 40 meters from the target as he aims his arrow at a bullseye. He shoots the arrow horizontally with a velocity of 90 meters per second. So we're going to calculate how far below the bullseye the arrow is going to hit. So I actually usually like to draw a picture on these. You don't have to be an amazing artist. You'll see I'm not. But just to get kind of the idea of what it's going to look like. Okay, so I have this archer, and he is shooting an arrow. What's going to happen is the arrow is not going to go straight. We have gravity to thank for that. So the arrow will curve down. So right here, I'm going to say this is the bullseye. You kind of got to use your imagination here. And so we're going to assume he's shooting straight at it and his arrow is the same height as that. So what's going to happen is he's going to shoot this arrow, and then the arrow is actually going to curve down. We don't know for sure that the arrow is going to hit the ground. We don't have evidence of that, but we know it's going to curve. The reason it's going to curve is because of gravity. And actually my trajectory here should be more curved. It should be kind of like that if you want to see a better picture of it. But whatever it is, it is going to be it is going to hit lower than the target. So probably he should have shot above the target. Okay, so we have a few things. This distance right here is my dx. This distance between where he's aiming at and where it actually is hitting is the dy. So those two distances are one thing. And actually, we already know what the horizontal distance, the dx, is. That is going to be 40 meters. So we have something helpful there. We do not know the dy, but that's actually what we're looking for. So the way that we're going to do this problem is by using the equations that we have above. So I am looking for dy, and one other little piece of information that's helpful is that my vy is 0. They tell you he is aiming the arrow and he's shooting it horizontally. When you know it's being shot horizontally, that means that there's no y velocity happening there. There is going to be a y acceleration, a vertical acceleration. That's going to be due to gravity, but there's no starting vertical velocity. So my initial vertical velocity is 0. All right, so what I'm going to do is, you'll notice I have two equations. The second equation actually gives me the thing I want. So the dy, and in this one, the vyt, that is going to equal 0 because vy is 0. And actually, most of the time with this second equation, you're just going to use it as dy equals 1/2 gt squared. You'll notice that we do know what g is. We know it's 9.8. We don't know what t is, unfortunately. So we need a little bit of work before we can use this equation. So this is going to be the equation that we eventually use. But before we do that, we need to find t. That's where this other piece of information that we have comes in. We know that dx is equal to 40 meters. So I'm going to use that first equation up there. And we also know that our vx is equal to 90 meters a second. So they give us two pieces of really helpful information there, and those are going to help us find the time. So I'm going to get 40 equals 90t. My time is going to be 0.444 seconds. So that's a helpful piece of information. From there, we can actually put that into the second equation. So that is going to be dy is equal to 1/2 times 9.8 times 0.444 squared. When you work that out, you are going to get approximately 0.96 meters. Okay, so for my second example, I know that there's a bridge. It is 176 meters above a river. So I'm actually going to show like the side view of the bridge so you can see what's going on. So we have this bridge. We have somebody up here, and they have a fishing pole, and they are going to throw their fishing line down to the water below like that. So that's what's happening there. So this black path is actually my trajectory of my projectile right here. And they tell us that it is a horizontal velocity, which means that we're tossing it straight out front. The other thing that we know is that this bridge, this distance from the top of this down to the water is going to be 176.4 meters. And we have this picture. We have, that is my dy. Okay, so the first thing they ask us to do is calculate the flight time. So how long is that fishing line going to take to hit the water? And I have two places where I can actually find that. I have this one, vx equals dx over t. The second one I have is dy equals 1/2 gt squared. You'll notice I didn't put in the vyt because I know it's 0. actually for all of these equations where you're assuming that there's no vertical initial motion velocity, you are welcome to just use that one. So since I know the dy, I actually can use that second equation. So my dy is 176.4. G, remember, is 9.8. And then I have t squared. So you're just going to solve this out just like you would solve any equation. You are going to have to take a square root at the end. But when you do that, you are going to get that t is equal to 6 seconds. So you might be able to guess that this is a very tall bridge. Okay, so the second one of these equations is the horizontal distance that the line travels. And that, if you look at your picture up here, that is going to be this point right here, which is my dx. So they're trying to figure out how far out did it go. For that one, you're going to use that first equation. You're going to use the dx is equal to vxt. So they gave us this nice piece of information, the 22 meters per second. So all you need to do is just plug in 22 meters per second, multiply that by the time, which we found was 6, and you will end up getting 132 meters. So for your last question, we have this beach ball that rolls off of a pier, and it hits the water 0.75 meters from the end of the pier. As with the previous one, I do think that you should pause this video and just try the problem, see if you can get it. If you're still confused, go ahead, you can watch it, but my recommendation though is try the problem and pause. You can rewind to the end, or you can fast forward to the end if you want. Okay, so for this problem, I went ahead, I drew the picture. So we know a few things. We know that it's going to hit the water 0.75 meters from the end of the pier. That's going to be my dx. So the other thing that we know is that it rolled off, which means that it wasn't kicked up or anything like that. So this is just going to be only a horizontal velocity, which means that our Vx is going to be 1.27. And so now we have two things. We're going to start with the flight time. And actually we know that Vx is equal to dx over t, or you can do it as t equals dx over Vx. And that is just going to be 0.75 over 1.27, which is going to give us 0.59 seconds. The second thing, our drop distance, which is the same thing as the height of the pier, that's going to be this thing in green. That's my dy. So I know that dy is equal to 1/2 gt squared. And I know that g is 9.8. I just found that my t was 0.59. So I end up getting that it's 1.710 meters.